Jagannath. Wake up, honey.
Whoa! What happened? Oh.
This is Harini, and as you can see, she's gonna help me on this science video just like she did with the pilot video. If you did not watch that, please subscribe to Jagannath's channel and also comment it and watch the pilot video. So, in this video, we're gonna be talking about electronic components and circuits. Electricity part 2. So, first we're gonna be doing components and then circuits. An electronic component is a basic electronic element. These electronic components can be used to be connected together into a circuit. Some components can be single item. For example, give me this. Thank you, Harini. A resistor, an LED, both of them. Okay. Capacitors, a small switch, not this yet, this one, a wire, etc. No, not that one yet. And some items can be multiple items. Some components can be multiple item, for example, and they are called integrated circuits. So, first we're going to be doing single item, and then we're going to be doing multiple item integrated circuits. So, the first single item component that we're going to be talking about is the LED, the great light emitting diode. Here you go, Harini. Hold it for the class. So, this light emitting diode, I said it myself, is a component that emits light only when current passes through it. This is the symbol for the light emitting diode, or LED. So some LEDs are called RGBs, which means they consist of the colors red, green, and blue, which combine together to form different colors that shine brightly. Right, Harini? So, in a circuit, it always has to be with the resistor, the LED always has to be with the resistor in series. That's because the LED only needs a little bit of current to shine bright. Amperes are what measure in current. Milliamperes are 1,000th of an ampere. It needs thousandths of an ampere to glow. If the current applies like more than that, then it will die out and not work. So the resistor slows down that current voltage so that it will shine brightly and pass its light. Resistor. So, just like as Harini said in song form, we will be talking about resistors. So, these awesome resistors control the amount of current and voltage in a circuit. So hold this for me, please, would you? The symbol for resistor is this. That is the resistor symbol. So, a person called George Ohm stated that resistance, current, and voltage are all related in his theory, Ohm's law. So in this Ohm's law, voltage is V, current is I, and resistance is R. It says here that V is IR. That means voltage is current times resistance. Then what is current? Current is voltage divided by resistance. And resistance is voltage divided by current. So that is Ohm's law, resistor, and resistance.
Number 1 circuit.
So just as Harini said, we're doing our first experimental circuit. So let me tell you a law that's really important in the science of electronics. So this is the power signal, symbol. This is the LED, just as I told you, and resistor. But this is the power signal. That's because it can come from a power source like the socket, which I told you in the electricity part 1, and this battery. It can come from both energy. That's why it's called the power symbol. So this longer one is the positive side and the shorter side is the negative side. So electrons flow from negative to positive, but current flows from positive to negative. That is called conventional current. So let's start building the circuit, shall we? So first, let's connect this red wire from positive to positive side. So here it is. So we connect this one. Maybe other side is better. So we connect it into it fully. No, this is this the wrong wire or? Okay, let's try the negative side first. Oh, it is the right wire. I put it like vertically. Note that it has to be horizontally. So these lines are horizontally connected, and these short lines are vertically connected for each. So now let's do the resistor. Fun part. So we connected from the positive side. So like that. So let's put it in there. Wait, not here. Over here. Then like this. Then we put it here. Here. So it starts from the negative, positive side. So like this. We just give us some time. Like it's hard to put, but we can do it. Just give us some time. A little help. Did we do it? Yeah, we done it. So the resistor is connected. Now we just need the LED. So it's connected from here to here. The negative, positive to negative. So, see Harini? Can you help me with this? Mm-hmm. Now we are doing the LED from positive to negative. So now over here, this positive is connected to the resistor, and the negative is connected to the negative terminal of the battery, just like here. The longer sides of the LED is positive, so it's connecting with the resistor. And the negative, I'm gonna connect it right to the negative terminal. Right about somewhere over here. Okay, so the circuit is almost finished. We connected this. Now all we need is a power source over here. Right?
Yeah.
Okay, so let's just connect the negative side first, then the positive side, and let me trust you, it will glow. Hope. Okay. See? the circuit works. Let's just put it again. It's not coming. There we go. Ah. So the circuit works. We have everything. We have the power source, we have the LED, we have the resistor to make sure the current is just right for the LED. And the circuit is finished because the battery is connecting its energy to the positive side, and then it's going to the resistor, and then it's going to the LED to light it up, and then it's going back to the negative side to make the light glow. This is a breadboard circuit. The breadboard is this, all this white stuff. So that is number 1 circuit.
Number 1 circuit. Switch.
So here is this push button switch. It's a common switch, the push button switch. You just need to push a button. So the switch connects one pin to another in a breadboard. See, take a closer look in this breadboard. These all are pins. It connects one pin to another like that in a circuit. So this is the push button switch. The switch is a component that connects one pin to another. In order to pass the current, the circuit needs current from the positive side back to the negative side. Remember, that's called conventional current. So when you pass the positive energy to the negative, then the light lights up. But if you disconnect the positive or the negative, then the light stops. A switch is basically a way to connect and disconnect the current. This is the symbol of a push button switch. See a closer look at the bottom of the switch. The switch, this push button switch here has 4 terminals. 1, 2, 3, 4. But 2 terminals on each side are connected together. So basically, it has only 2 terminals. So that is all for switch.
Number 2 circuit.
So this time we'll be doing a switch circuit too on this breadboard. But before we do that, let's just focus on the circuit diagram. So this is the power symbol, battery, socket, and it can only be a battery and a socket, of course. So next we have the switch. No matter where it is in position on the circuit, it will always turn on and turn off the circuit. Next we have the resistor and of course LED. So here we explain the circuit diagram. Now we see the small switch over here. So here has 4 terminals. If we put it sideways, you can see 2 of the terminals, I hope. Yeah, here. 1, 2, 3, 4. So these 2 are equal. These 2 are not. These 2 are not. So if we put one component, such as a wire over here, connecting to here, then, and if we put one component, let's say over here, then it will not work. It's still the same side. But if we put a component over here, then it will work because these are 2 opposite terminals. So then it will connect to the resistor, which resistance, and then LED, and then back to the negative terminal. So let's see if we press the switch. It lights! Because the power lines are connected, the battery is connected so that it gives us energy. Then the switch is connected with the components and the wire. Then it summarizes that the switch also contributes to the circuit. So that is number 2 circuit. So till now we learned about resistors, LEDs, and switches, and how they work, and what are they. So now we're going to be talking about an amazing component called the capacitor. Here's a closer look. Here is the capacitor. So think about a capacitor as a battery with very low capacity. It can be charged and discharged just like a battery. The capacitor can be used to show time delays, for example, a light blinking, or regulating speed in a fan. Look up. See, that uses a capacitor. And capacitors are there are two kinds of capacitors. Polarized and non-polarized. You can figure out if these are both capacitors, but which is polarized and which is non-polarized. A polarized one has a positive and negative terminal. So this is the polarized one, definitely, because the longer side is the positive and the shorter side is the negative. And this is not a polarized. So that concludes polarized and non-polarized. Let me just put it back where it belongs. Okay, so these are two symbols for the capacitor. If there's a plus, that means it's polarized. So that is capacitors. So we did number 1, number 2 circuits. And they explained us how resistors, LEDs, and switches work together in a circuit. Now we're adding one extra component to this circuit, a capacitor. Number 3 circuit number 3. So this time we're adding a capacitor. This is the circuit diagram in which we're going to do. This is the battery, this is the polarized capacitor, this is the switch, this is the resistor, this is the LED. So the battery charges the capacitor, and when the battery is disconnected and this one is gone, then the capacitor itself was charged, so it can power the LED by itself when you turn on the switch. So before we discuss the breadboard circuit, I would like to discuss that the battery is parallel to the polarized capacitor. See? And also the capacitor is polarized, and the polarized capacitor is parallel to the resistor and LED. So now we are going to discuss the circuit number 3. So I've put the positive terminal over here, and then it meets up with the positive terminal over here, and then you can start the charge. The battery charges up the capacitor, the polarized capacitor. So now the capacitor is being charged by the battery. Let's take off the battery in 5, 4, 3, 2, 1. Let's take the battery off. The battery is removed from the circuit. But how can it glow? Because the battery has charged the capacitor. Let's watch it. See? It glows, but only for a tiny bit. But why? I wonder why. Because this capacitor is only 100 microfarads. It can only charge a little bit of energy to make that light blink. But if you use 1,000 microfarads capacitor, then it would have shined more. The LED would have shined more. Thank you for watching Electricity Part 2. Please